about the Chihuahua and the St. Bernard was their fossils, would we say, oh, these are just two variations of the same species? Of course we wouldn't. They'd be categorized as totally separate species on some kind of very interesting evolutionary pathway. But it would be completely wrong, because we know they are the same species. And we know we can get this kind of tremendous diversity from the same species. We look, for example, in a 35-year period, we see the changes occurring in the skull of the purebred bull terrier. How are these changes occurring? They're occurring by what is a tandem repeat sequence in certain regulatory sites of the dog's DNA. Now, again, my challenge would be, if all we knew about the purebred bull terrier was fossil evidence that looked like this, do you think that paleontologists say, oh, this represents a 35-year or 45-year period of time where we had this kind of change? Of course not. The interpretation would be, that probably represents several million years worth of change of that particular organism. Again, that would be wrong. Now, if creatures alive today we know can give this kind of diversity that would create misinterpretations in the fossil record, then how do we know we're interpreting the fossil record correctly? And of course the answer is we clearly do not. We clearly do not. Okay, where do you get a small horse? You get a small horse from a large horse. Lucy. I love Lucy. When I was a lot of you students' age, Lucy was the big thing. Some 40% of her skeleton was found, which from a humanoid perspective to evolutionary paleontologists, this was extraordinary. And the conclusion was that because her skeleton was so complete, this would prevent us from making all kinds of errors in putting her together that had kind of embarrassed the evolutionary community in the previous part of the 20th century, where they would find a tooth and misinterpret it, find the rest of the skeleton and realize it was, things like an extinct pig. So the recognition was, okay, this is going to be able to prevent that from happening. Creationists immediately began to challenge if Lucy really was being interpreted correctly, and we were called all kinds of names. And I know we were because I was there, I lived through it. We were called all kinds of names. You stupid idiots, this is proof positive. This proves you don't care anything about science. You don't care anything about the evidence. Because look at this clear evidence as demonstration of a link showing how human evolution occurred. On a NOVA episode, October 11, 1994, Dr. Owen Lovejoy, who's the primary anatomist that worked on Lucy, just matter-of-factly described how when they got analyzing the pelvic bone and the tailbone of Lucy, they didn't like how it fit together because it didn't allow her to stand upright and walk like a human, which they knew she did. It punched her over like a primate. Well, we know that can't be true. So they reshaped her pelvis. Based on what? Based upon nothing but their own evolutionary interpretation of how she was supposed to look. And to him it was just, what's the big deal? Because evolution is the guiding interpretation to develop the evidence that what? Supports evolution. So I would challenge as a creationist, why would I accept out Lucy as any kind of fossil evidence illustrating human evolution? Because evolution was guiding the process of putting her together to begin with. Just a second. Okay? Talk about the human genome for just a second. The human genome is the composite of all the DNA sequences in the nuclear DNA that is in the nucleus of the cells of the human. Okay, the genome is still being sequenced, but a lot of it has already been sequenced, and it's been spending a lot of taxpayer money to spend that, so you're glad to know where your money's going. In 1975, way before the genome was sequenced, a number of scientists proposed the idea that the human and chimpanzee gene sequences were very similar. And this became known as the 1%, or as I would call it, the 1% myth. And that is that humans and chimpanzees only have about a 1 to 2% difference in the sequence of their genomes. Now, You may not be able to read this, but I'll read it for you. This was a little science magazine that was handed out to my youngest son when he was in 8th grade, and it says, should chimpanzees be reclassified as another species of human? I would challenge those of you that are Christians to realize that the conclusions being drawn by evolutionists in these matters aren't neutral. They're not without impact in society. And their impact, that I would say, is very unbiblical. Using this kind of thinking, the Spanish Parliament a couple of years ago seriously considered giving human rights to primates. This is serious. But let's look at the science for just a second. Okay? There's a lot of differences between the human and the chimpanzee genome. But let's just give one example, because I don't have all night, unfortunately. Okay? There's 11.5% difference just in the size of the genomes. So if the chimpanzee genome contains 11.5% more DNA than the human genome, how can there only be a 1 to 2% difference? Good question. Dr. Pablo, who was initially a very strong advocate of the 1% idea, or what I call the 1% myth, in 2007 was quoted as finally admitting that I don't think there's any way to calculate the number. In the end, it's a political and social and cultural thing about how we see our differences. In other words, it was never really about the evidence. It was about an evolutionary social agenda. I'm not saying all evolutionists are involved in that. That's not the point. But I am saying that there is that which always carries over into society. And this was one of them. Okay. Polyconstrained DNA. This is a little complicated. I'll try to make it somewhat simple, but I don't have enough time to explain very much of it. Okay. DNA is a double-stranded molecule. You recognize if you took a genetics class, it has that nice helical staircase nature to it. Okay, each strand, the sequence of each strand is dependent on the other strand. So they're interdependent. They're not totally separate. The sequence of one strand directly depends on and directly influences the sequence of the other strand. Initially, what was thought in a very simplistic view was that one strand of DNA called the sense strand was transcribed and RNA was made from it. And then genes would make that RNA, and the RNA then would be translated to proteins, and then some RNA used for other processes. Okay, we now recognize that most, if not all, DNA sequences are not only functional, but polyfunctional. With the discovery of introns and exons quite a few years ago now, it was realized that one gene can actually be responsible for making multiple copies of different kinds of RNA by the ability of splicing and resplicing them in different orientations. But then it was also recognized that the antisense strand, which was thought to be just a template for replication, also now makes RNA. So we have this very tight constraint that a mutation occurring on one of the strands not only affects potentially the functioning of all the RNAs that can be made from that strand, but also all the RNAs made from the other strand. So now we have a situation where trying to introduce even a single mutation has effect all across the board and not just right in one gene for one protein or for one functional activity. This polyconstraintness not only defies an evolutionary explanation of how you would originate this, and you got to think about it, the evolution claims to account for the origin of things. How, from an evolutionary explanation, could you originate this type of polyconstraint? Because it would be defying you every step you tried to evolve it. But once it's evolved, then how can evolution deal with this? Because this would stop evolution cold. There would no longer be the ability of doing the advanced transformations that evolution requires, because the polyconstraintness says you can't do that because you mess up too much. You're not just dealing with one protein of one gene. You're potentially dealing with a lot of proteins of a lot of genes. Okay? The human genome itself is a masterpiece of design that defies the explanation of known mechanisms. Now, creationists do not say that suddenly we introduce God into everything. What creationists say is that there comes a point in time where we have to say, what is the scientific explanation? What's the scientific way to look at this? Do we look at it as a product of natural, or do we back off and say, This defies our natural understanding. This defies what we can explain. If we look at the genome as a book metaphor, we have to bear in mind that the human genome, like all DNA, is a three-dimensional structure. It's not read in a two-dimensional world, it's read in a three-dimensional world. So that gives it enormous information capability. Okay, so if we use a book metaphor, the genome is a book with a highly technical text. There's no known counterpart, certainly not in the human technology world. No known counterpart. One sentence is equal to 100 related but different meanings. And notice related, it's not like they're independent meanings. There are 100 related but different meanings, yet all compatible to hold the textbook. It contains numerous cryptic writings that are decoded by things such as transpositions, rearrangements, and the epigenic state, which is a whole nother topic we don't even begin to have time to get into. So, what this would mean very simply is if you took a 1,400-page book of War and Peace, you'd be able to print it in such a way that it could be read on 14 pages. Now, my challenge is, could you read that book? Could you write that book? All of combined human understanding cannot write that book. Yet, evolutionists will tell us that book was written by a natural random process directed by a blind force called natural selection. How's that scientific? How's that a scientific explanation of a book that defies our understanding? That's like saying, as much as bad as you may think Windows Vista is, maybe that's not the best example, that's like saying that Windows Vista was written by some blind random process that just had a selection process come in and try to clean it up. One would look at you with daftness saying, that's ridiculous. You can never get anywhere writing a program like that. The human genome makes our computer programs look moronic by comparison. And yet that's what the scientific community is trying to tell us. Oh, it was written by, over a long period of time, by a bunch of monkeys typing on typewriters. Remember Huxley's example? Monkeys on a typewriter, printing, typing out Shakespeare. This is what I call the simplistic mutation proportion bell-shaped curve. I've actually been in debates where evolutionists have tried to support the idea, essentially, that you get mutations, some are good, some are bad. The good genes stay, the bad genes go. My first question to them is, when did you last have a genetics class? Because I think you need to go back and take a little bit more genetics. And even using the evolutionary concepts of beneficial mutation, which we'll come back to in